Today I'd like to introduce you to HCL Workload Automation, also called HWA. I'll start by showing you the Dynamic Workload Console, which is a simple, single point of control for creating, deploying, monitoring, and managing your workload. The Dynamic Workload Console, or DWC, is the primary tool used to interact with and manage your day-to-day automation work in HWA. We'll start by logging into the console. The default landing page is divided into 3 sections to help you be productive quickly. On the left is the Dynamic Workload Console that provides you access to the most used HWA task pages. Connect Your Engines is for administrators to connect the Workload Console to the master engines. Design Your Workload is the Workload Designer interface for defining and deploying automation objects. Monitor Your Workload is where you monitor and manage your deployed work. And the dashboard. This is where you can see a single-page overview of the status of your environment and work. In the middle is the Self-Service UI section. The 2 links here are the Self-Service Catalog and the Self-Service Dashboard. The Self-Service Catalog is where you set up predefined work to be accessed via your mobile device, and the Self-Service Dashboard is where you monitor this work. The technology, naming convention, and how you interact with your work is comparable to standard mobile applications. On the right is the Application Lab. The Application Lab is a simplified user interface used to create and manage basic workload. Only a few of the features available in the Dynamic Workload Console are available in the Application Lab to use. So with this in mind, you'll find the majority of your time will be spent in the Dynamic Workload Console section of the interface. Now we'll dive deeper into the Dynamic Workload Console, starting with the default dashboard. In the default dashboard, you'll see an overview of the HWA environment you're currently logged into. You'll see the engines available, the status of your workstations, unavailable and available. Here are the prompts that need to be answered. In the large center section, you'll see the current status of the workload in the plan. You'll see what's blocked, canceled, completed successfully, what is in error, in ready, what is currently running, and what is still waiting to run. At the bottom, the dashboard shows you the status of any jobs you've defined as critical. These are typically SLA jobs and are monitored separately to allow you to take action if there is a possible risk or high risk of them not completing on time. Up on the right, you'll see jobs in error. You can drill down to see the details of the jobs and take action if needed. You can manage your appended jobs from this screen by taking actions like checking job logs, canceling, or rerunning. The dashboard shows you late jobs, which are jobs that have missed their scheduled start time. Minimum duration jobs, which are jobs that completed sooner than expected. And maximum duration jobs, which are jobs that ran longer than expected. Plan progress shows you the percentage of the full plan that is completed. And finally, log messages. These are messages sent to the operator console and range from informational to critical. Another great feature in HWA is that you can create specialized dashboards for management, admins, schedulers, operations, or application teams to do their work quickly. To do this, you simply add a page, name it, choose the layout and options, and click OK. Next, you'll open the dashboard widgets and choose the widgets you want to use on the page. Drag them onto the form, create the queries the widgets will use, share the page with the users or groups that will use it, and then save it. Next, we'll go to the simple interface used to monitor your workload. This is the Monitor Workload page. You first pick from the drop-down list the type of object you want to monitor, like jobs, job streams, or workstations, and click Run. Let's look at workstations first. The list here shows us all of the active workstations in the plan and their state. You can select a workstation and right-click on it for more management actions. Here you can do Start, Stop, Link, Unlink, and take other actions. You can even choose to upgrade an agent using our Zero Downtime Upgrade feature. Zero Downtime Upgrades is an exclusive HWA feature allowing you to upgrade agents without having to negotiate with application teams for a batch outage window. This is because jobs don't need to be stopped to do the upgrade. And if there's a problem with an upgrade, the process will automatically stop and back out by putting the original version of the agent back on the system. If you need to, you can even downgrade an agent. Now let's go back and choose job streams. You can see in the query line the command line syntax that can be used. But if you don't know the command line commands yet, you can click on Edit and down below in the Filter section, choose exactly what you're looking for. You'll notice as you add filter options that the command line query information gets updated. You can also add a task name and save the query for future use. Now we'll open up a saved query and refine our search using the quick filter. The quick filter allows you to quickly find objects on a page. Let's look for the cross-platform stream. If you've determined that this stream needs to run now, all you need to do is release the dependencies and the job stream will launch. We need to fill out our audit information. You can see the job stream was successfully submitted. And now we'll take a look at this and watch it run in the job stream view. In the job stream view, we see that the stream is launched, and Job 1 in green has completed successfully. Job 2 in blue is running, and the jobs in gray are waiting for successful completion of Job 2. You can monitor the stream here until it completes. Now we'll create a new job and a new job stream in the Workload Designer. On the left-hand side of the Workload Designer is Create New. Here you choose which automation object you want to create. You can create jobs, job streams, workstation classes, variable tables, and run cycle groups. In the center section, you can search for objects that have already been created to modify, delete, or copy them for reuse. Choose the object type you're searching for, and then simply type into the search box to pull up a selection list. You can click on a checkbox and then open the item in either Edit or View Only mode. On the right side, you'll see a list of the most recent activity. You can click on one of these items to view it or modify it. Before we create a new job, let's see how the built-in versioning works. This job stream has multiple versions. We'll click on the Versions tab and then we'll choose two versions to compare. We'll choose the current version and two versions back. You can see using Compare that the job in this job stream is changed. Compare will also show you any other differences the two job streams may have. You can not only compare versions, but with HWA you can restore to any previous version by selecting the version you want and clicking Restore. Now let's create a new job. When you choose New Job, the first thing you'll see is a complete list of all the job types available within HWA. All of these job types are available at no extra charge. You get all of the native job types like Windows, Unix, and Workload Broker. All of the ERP job types like SAP, where SAP is certified by SAP and tightly integrated, Oracle E-Business, and access methods used by PeopleSoft and other applications. The HWA Cloud Pack with job types for Amazon, Microsoft Azure, IBM SoftLayer, Salesforce, and other applications. You also get file transfer and coordination jobs. This includes shadow jobs. Shadow jobs are used for cross-environment dependencies. File transfer jobs for FTPing or SFTPing data files. Hadoop distributed file system jobs and Sterling Connect Direct jobs. The next category is business analytics. This includes job types for Big Insights, Cognos, DataStage, Oozie, PowerCenter, and other BI applications. Next are the automation utilities. These are used for internal processes and includes the centralized agent update that allows you to schedule upgrades of your agents. There are more job types available, but in the interest of time, let's skip forward and create a Unix job. The first thing you'll notice is that some of the tabs have red asterisks. This indicates that required information is needed on that tab. You'll also note that some of the fields are yellow. This indicates that those fields are required. We start by filling in the name of the job, the workstation name, which we can also search for, and the user login for the job. Add a description of the job, add your successful output conditions. If no condition is specified, by default, 0 is successful. And you can set up other custom output conditions that don't change the status of the job. Now we'll go to the Task tab and set up what the job is going to do. A job can be set up to run commands or scripts, and either can use variables. Now let's look at the recovery options. The default action if a job bends is stop. You can also choose continue, continue after prompt, rerun, and rerun after prompt. The rerun feature is very powerful. By default, choosing rerun reruns the job immediately. But you also have the option to retry running the job after a set number of minutes or hours. We'll set the retry time to 15 minutes and the number of attempts to 2. For dynamic jobs where you're running jobs in a pool, you can tell the system to rerun the job on the same workstation it ran on originally. You can also define a recovery job. A recovery job could do something like resetting a database so a job can be rerun. Now we'll set this job back to stop, verify that everything is complete, and we'll save it. Because auditing is turned on, we fill in the audit information. We verify that it's been saved successfully. We close this job, and now we'll create a new job stream and add jobs to it. We choose Create New Job Stream, and we close the working list. You'll see we have the same red asterisks on the tabs and the same yellow for required fields. We add the job stream name, and then we add the workstation. Now we'll give ourselves some more room and look at the job stream options. A job stream can be set up in draft mode or in active mode. You can have a valid to and valid from dates, description. You can set it up with a variable table. It can be monitored, and you can also add in comments. Start condition is for condition-based workload. You can start your workload based on one of the following conditions: one or more files being created, one or more files being modified, or a job completing with its output condition satisfied. You can define a job with the carry forward option. Carry forward allows a job stream to be carried forward to the next production plan if it hasn't completed before the end of the current production plan. You can limit the number of concurrent jobs able to run in a stream. You can set the priority of go, high, or a specific value. The default value is 10. You can define a non-working days calendar. You can use the default or choose a specific calendar if you want. And then you can look at the actions that it will take if there are multiple instances of that stream in the plan. Those options are run the new instance in parallel, don't start the new instance, or queue the new instance. Under time restrictions, you can choose a time zone. You can set the earliest start time, which is the earliest time a job or job stream can start, taking into consideration all of its dependencies and resource requirements. You can set the latest start time, which is the time before the job or job stream must start. The job or job stream can start before the latest start time, provided that all other dependencies are satisfied. If a job or job stream reaches its latest start time, there are some additional actions you can perform. Those are suppress, continue, or cancel. And finally, you can set a deadline time. The deadline time is the latest time by which an occurrence of a job or stream must be complete. On the Dependency Resolution tab, here's where you tell HWA how to handle the dependencies when you have multiples of the same job stream in the plan. You can tell the stream to resolve to the closest proceeding, the stream on the same scheduled date, a stream within a relative interval, or a stream within an absolute interval. We'll set this stream to closest proceeding. You'll see on the Versions tab that there are no other versions available. This is because this is a brand new stream that has not yet been saved. Let's move forward and add jobs. There are multiple ways to add jobs to a job stream. The first way is to right-click on the job stream name, and you can add jobs, you can add dependencies. You can also submit the job stream into the plan or take other actions. But you can also just go to Select an Action and click on Add Jobs. This pulls up a search box that allows you to type in the full name of the job, or you can search using a partial name and wildcards. You just select the jobs and add them to the job stream. Now we'll go back and add more jobs to the job stream. So now we have 6 jobs in the job stream. Let's go to the graphical view and add the dependencies. We set up the jobs in the basic logical order we want them to execute in. Then we quickly add the dependencies. We take a final look and make sure it's set up the way we want. And then we go back to the Details section to set up our run cycles. We right-click on the job stream name and we choose Add Run Cycle. The run cycle options appear at the bottom of the page. We navigate there to define it. Run cycles are easy to use because they use natural language to schedule your job streams, and they can be combined into reusable run cycle groups to handle complex scheduling scenarios. To create a run cycle rule, you just name it. We'll leave this as RC1. You can put in a description. We'll call this one Test. You can set start and end dates for when you want this run cycle rule to be available. You can assign it a variable table. You can set up a rule for non-working days, telling it to not be selected on a non-working day, or tell it to select the nearest workday before or after a non-working day. Or you can tell the run cycle to be exclusive or inclusive. Now we'll create our run rule. The run cycle rule defaults to calendars, but you have a lot of options to choose from. The simple rule allows you to go in and choose whatever days you want this job stream to run on. Because run cycles are so powerful, you'll find that you'll need very, very few calendars. But you'll still have calendars available for you to use. When you choose calendar, all you need to do is go in and search for the calendar you want and pull it in. You'll also have the ability to offset calendar days if you need to. The next option is the daily rule. This allows you to run your job stream every day, every 2 days, every 3 days, every 4 days, etc. And you can also do the same with work days and non-working days. You can see in the upper right how our parameters have been automatically changed for you based on how you set up your rule. You can choose to create a weekly rule for your job stream. You can run your job stream every week, every 2 weeks, every 3 weeks, and you can decide which day or days of the week you want it to run. The next option is to run it monthly, by month day. You can choose every month, every second month, every third month, and the specific day or days of the month you want it to run. You can choose monthly by weekday, choosing specific days of the week you want it to run. You can choose yearly for your fiscal year-end workload. And finally, you can choose Run Cycle Group. Create run cycle groups for difficult scheduling situations and reuse them when you have other job streams that need to run on those same days. We'll go back and set up our job stream to run every day. Now that we've created our basic run cycle, let's go take a look at it in the Run Cycle view. The Run Cycle view shows us a visual representation of when our job stream will run. You can see in the green that it's going to run on those specific days. But let's say that we don't want this job stream to run on holidays. To do that, we can either click on the Add Run Cycle button, or we can go back to the Details page and add it there. In the second run cycle, we'll select the holidays calendar, and then we'll tell it to exclude them. We'll give it a description, and then we'll go choose our holiday calendar. We don't need to offset the calendar. We go back to the General tab and mark it exclusive. And we go back to the Run Cycle preview. The holidays are marked in yellow. They are now excluded, and the job stream will not run on these days. Now that our job stream setup is complete, we'll save it, and then we'll submit it for a test run. We select Submit Job Stream into Current Plan. Again, because we're submitting something into the plan, we need to fill out our audit information. The auditing feature remembers your last entry in case you need to reuse that same information. HWA confirms on the upper right that your job stream has been submitted. And now we'll go to Monitor Workload and validate that the job stream ran. We do a quick search for the job stream. We see that the job stream's already executing. We click the checkbox, and then we pull it up in Job Stream View. Job 1 is completed successfully. Jobs 2, 3, and 4 are running. The job stream page view refreshes automatically, but you also have the option to use the refresh button. Jobs 2, 3, and 4 have completed successfully. Now Job 5 is running. Job 5 is complete and Job 6 is running. At this point, let's take a look at how conditional dependencies work. Conditional dependencies allow you to define job flows with alternative branches. These branches execute based on a condition or a set of conditions. This is like using if-then-else statements for your automated workflow. You can use return codes, job status, output variables, and job log information as conditional logic to determine the start of a successor job. I have a simple conditional dependency job stream setup that goes down one path or another depending on the output of a job. In this case, the path is determined by whether or not the first job abends or is successful. The first job is the trigger job. It's defined so when it completes with a return code of 0, successful, it launches the condition successful path and suppresses the condition stop path. Let's take a look at how this works. In this case, I've already run 2 of these job streams, and they each have a different outcome. Let's take a look at them. In the first job stream, the first job is completed and sent a return code of 0. This means that condition success was satisfied and the condition success job or path was run. You also see the condition stop job or path was suppressed. Now let's take a look at the other example. You see in this example that job 1 completed successfully even though a return code of 5 was returned. This is by design. The return code of 5 satisfied the condition stop dependency and launched the condition stop job or path. and you'll notice the condition success branch was suppressed. This can be a powerful feature when you have automated workload that needs to make and/or decisions to execute properly. Let's take a look at another exclusive HWA feature. This is the HWA What If Analysis feature. What If Analysis allows you to visualize the current plan in real time, showing the current status of jobs and job streams, the planned start and end times, deadlines, and the risk levels associated with each job or job stream. You can launch What If from any job or job stream in a distributed environment, or from any critical job or job that is part of a critical network in a ZOS environment. You can use What If to analyze and determine solutions for issues like a job or dependency is changed in a critical job stream, causing a delay, a required file is late in arriving and a critical business process hasn't started, a job in a job stream is late or running long, affecting a critical SLA job downstream, a workstation is unavailable or is going to be unavailable for a period of time. How will a change affect your batch or SLA? You can even use it as part of your validation process for new job streams to ensure the new work will run and perform as expected. In short, if there are issues in the plan you need to analyze and fix, you can view the work in a number of different ways in HWA. Let's give them a quick look. You can view the jobs in a job stream and drill down to find an issue, or see the job log of a late or questionable job. You can view the stream in Job Stream View to see the structure of the stream and determine where the slowdown is. You can see here that 6 of the jobs have already completed, Job 7 is still executing, and the last 3 jobs are waiting for Job 7. If a critical job is involved, you can look at critical jobs using Monitor Workload and drill down for more information. You'll also find here how to get to critical path, the hot list, not completed predecessors, all predecessors. You can get to What If from here, and also the job stream view. I have a demo job stream set up to illustrate how this works. Let's look at it in the What If interface. What If Analysis is a snapshot that visually displays in a Gantt view. Each job involved in the completion of the overall work is presented as a horizontal bar that represents the start time and end time of the work. Again, What If can be opened by selecting a job or a job stream and clicking on What If. Once you're in the interface, you can add more jobs or job streams and their predecessors and successors to the Gantt view by using the Show Jobs and Show Job Stream buttons. You can see to the left the list of the jobs and the job streams that were pulled into the Gantt view. And you'll see to the right a visual representation of the status of each of these jobs and their dependencies at the time the snapshot was taken. To better understand these states, we provide a key. This shows you earliest start time, baseline, deadline, name, dependencies, satisfied dependencies, and you can even turn off an individual key. In the Gantt view is where you can make changes to determine the effect the changes will have on the final critical SLA job completion time. If you have 2 jobs that are expected to run long due to increased data, you can adjust their runtime and look at the result. If you want to see the effect of adding or removing dependencies, you can also do that. We just highlight and delete the dependency. And you'll note that the critical job at the end has now moved its end time. Let's see if removing any other dependencies has a positive impact. Let's try the dependency between Job 6 and Job 7. We see that that had no impact, so let's go back and undo those 2 changes. You'll see that the job is returned to its original end time. After testing a few different changes, we determined that deleting the original dependency is the best way to speed up the completion of the last job. So we delete that dependency. We go to check for issues. There are no issues. And then we go to the More Actions tab to apply or print the changes. Under Apply or Print Changes, you see the actual changes that you're going to be making. You can skip any individual change that's listed. You can print them, and you can apply them. You can show the commands that will be executed by the system to make your change. You can take a look at changes that you made that are not applicable, so these are things that you won't be doing because they won't save you any time. The justification comes up, which is our auditing. We fill in the audit information. Again and again, click Apply or Print. In this case, we'll click Cancel. This gives you a brief overview of the powerful yet easy-to-use what-if analysis feature. Now let's move on to the next feature. Let's take a quick look at the event processor. The Events feature in HWA allows you to define rules that can trigger on-demand workload. The object of event-driven workload automation in HCL Workload Automation is to carry out a predefined set of actions in response to events that occur on nodes running HWA. But it can also take action on non-HWA nodes by using the sendEvent command line. This allows you to submit workload and run commands on the fly, notify users via email, open incident tickets in Servicenow, and take other actions. The main tasks of event-driven workload automation are: trigger the execution of batch jobs and job streams by reacting to a real-time event occurring, reply to prompts, notify users or admins when unusual conditions occur within your scheduling environment or batch, and invoke an external command or product when a particular event condition occurs. I have a few events already created, so let's take a look at them. Event-driven workload automation is based on the concept of an event rule. In HWA, an event rule is a scheduling object that includes the following items: events, event correlating conditions, and actions. Let's take a look at two of these rules. In the General Information section, you'll name your event rule. You can set it to draft or leave it active. You can select the time zone. You can set valid to and valid from dates. Also, daily start and daily end times. And add a description. Let's look at the event categories on the left. We have scheduler events, SAP monitor events, file monitor events, events that monitor the application itself, dataset monitors, and custom events. Under scheduling events, you can choose job status changed, job canceled, job did not reach minimum duration, job stream until, or any other event. For SAP, you can monitor an SAP event on an extended agent, an SAP event raised on a dynamic workstation, an IDOC event, and numerous others. The file monitor events include log messages written, file created, file deleted, and modification completed. There are events to monitor the application itself. You can monitor message queues filling up, the file system space, and also specific application processes. The next category is the dataset monitor, where you can choose read completed or modifications complete. The last category is custom events, where you can set up generic events and update events. Let's look at this open event definition. What this event does is sends an email every time a job upends or fails. For this, I use the job status changed event from the scheduler plan events. When you highlight an event or an action, the properties for that event or action show up below. In this case, for the job stream workstation, I've chosen all agents that start with the word agent. Then I've chosen all job streams, all job names, and the error status. You also have the ability to select additional properties. Each event or action will have different properties you can add. Next, we'll look at the actions that are available. For Workload Scheduler for ZOS, you can add a job stream into the plan. For the distributed scheduler, you can add Submit Job Stream, Submit Job, Submit Ad Hoc Job, and reply to a prompt. There's only one choice in the Mail Sender plugin action, and that's Send Mail. This is the one that I've chosen for this event. By highlighting the Send Mail action, you can see the properties for it below. Add your email recipient. This can be a group or an individual. You fill in the subject. You have the ability to add variables and ASCII text. Finally, I've created the body of the email. I've crafted a statement that says Job X on this workstation has abandoned or failed. Please investigate and correct the issue and either rerun or cancel the job in HWA, whichever is appropriate. The error message of the job was, and then I use the variable to return the error message directly from the job. You'll see that the additional action properties that can be added to the email are CC and BCC. I've also added in the message logger action. This allows HWA to track the events properly. In the generic action plugin, your option is to run a command. You can forward an event to the IBM Services Manager console. You can open a ticket in the Smart Cloud Control Desk. Again, this is the message logger, which you see to the right. IBM Console Event Forwarder. And the last category is Servicenow, where you can open an incident ticket automatically. I'll show you how to set that up next. The first thing you'll notice is that this event uses the same job status changed event type used in the previous example. It's set up to look for all jobs in error. In the action section, we've chosen Servicenow and Open Incident. We highlight the action and scroll to the bottom to fill in the properties. I filled in the short description. The priority of the ticket has been set to 3. The description of the ticket has been set up using variables and ASCII text. I set up a URL so HWA can contact Servicenow. I added a username and password so HWA can log into Servicenow and open a ticket. And then I entered the Servicenow assignment group the ticket will go to for resolution. You can also add additional properties like affected CI, state, close code, and custom parameters. Now let's see how we can tell if our events are working. To do this, we go into Monitor Event Rules. This is where you'll be able to see if an event rule is working, how many times it's executed, and the status of each execution. Let's move forward and talk about our next feature. HCL Workload Automation has a number of exposed services allowing you to create interfaces for extended automation. These are the J2EE interface, web services, and Restful APIs. I want to briefly show you some ways to use the Restful API services. HWA has built-in Swagger documentation for the APIs. You can use the Swagger documentation to learn the APIs and quickly test on the system. As a point of reference, anything you can do in the Dynamic Workload Console, you can do with APIs. Clicking on one of the APIs will open it. You'll see that it gives you implementation notes, the response class, the model schema. It gives you the response type, JSON, or JavaScript object notation. It lists the headers. Below that, you'll see the list of parameters. The parameters point out what's required and not required. You can put information into the body of the call utilizing the filters. And you can completely fill out your API call. At the bottom, you'll be able to try it out. When you click the Try It Out button, it runs your API call to ensure it returns the information you're expecting. The next thing I'd like to show you is the Restful API job type. In HWA, you have the ability to create jobs that make API calls. The calls that these jobs make can either be to the internal HWA system or to external applications. These jobs are created easily, just like any other job. You give the job a name, choose its workstation, fill in the description, you specify the output conditions, You move through the Affinity and Recovery Options tabs. You'll go to the Authentication tab to set up your username, password, and certificate information for the job. You go to the Action tab to put in the call that you're making. You'll choose a method. Your options are get, post, put, head, and delete. If there's an output file, you'll define it here. And any additional parameters go here. If you have a more complex call, you open the Body tab and put in your filter information. You save the job, and it can be scheduled like any other HWA job. Next, we'll look at how we can call HWA from a remote system. Let's submit a job stream using the remote command line. This emulates an external system calling HWA. First, let's take a look at what we're submitting. We're submitting a stream called Test API BGW. We'll launch the script to submit the stream. The submission is complete. Now we'll verify that it's submitted into the plan. Now you've seen a number of ways to use HWA's APIs. These are powerful tools to help you with your business needs. This concludes our overview of HCL Workload Automation. In the interest of time, I haven't shown you all of the features, but I hope you've seen enough to pique your interest. Thank you for watching.